Okay, so I think it's time to start this session. I'm very, 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 very excited to introduce Nico Matsakis. He's my dear colleague from PhD times at ETH Zurich. We TA'd together. We not only had the same thesis advisor, but also we TA'd compiler classes together. And Nico back then and still continues to impress me that the speed in which he can develop things. And I think his talk today is going to really be a testament to that. And you can see that he has a lot of fun doing really great work. And so I admire him as a colleague, but also as a human being. So Nico, please, I'm happy for you to give this talk, and the stage is now all yours.
Thank you very much, Stephanie, for that kind introduction. And I am indeed looking forward to presenting to you all. Let me just figure out if I can manage to share my screen. Okay. So I'm going to assume you can see it since I can. So yeah, my name is Nicholas Matsakis, and I would like to thank Stephanie and the other PLMW organizers, not only for the kind introduction, but for having me come talk. And I wanted to thank all of you for listening. And I have this talk, by the way, is online. You can see the URL down at the bottom, github.com, Nico Matsakis, PLMW'22, in case there's any slides you want to review or links you want to follow up, that sort of thing. So let me just tell you a little bit about myself. My primary claim to fame is that I've been heavily involved in the design of Rust. I've been working on it since 2011, which makes it a little over a decade, which is a little crazy. And I'm the co-lead of the Rust language design team, but I've also worked a lot on the compiler and kind of led some parts of its architecture and overall design. And I recently joined AWS, where I'm a senior principal engineer. I work on Rust here. And before joining AWS, I did other stuff. So most of the time that I worked on Rust, I was doing it at Mozilla. And I did a PhD, as Stephanie mentioned, with Thomas Gouros. But what you'll see here is that all that time I've basically been doing compilers and languages. That's pretty much ever since I took Samhanamara Singh's course on compilers at MIT, 6035, for those of you who know the numbers. I just kind of fell in love with that, and that's all I wanted to do. So I love it, and I hope some of you will too, or already do. My goal with this talk is to talk about some of what I've learned over that period about building languages and compilers. And I'm kind of having a lot more fun now than I ever had before. And so I wanted to spread the news on the way I'm working now and maybe get some of you interested in, maybe you'll find something that works for you. So one thing I do want to say is that I haven't always had such a good time. I appreciate Stephanie saying that, you know, she that I worked fast and so forth, but to me, I always felt ineffective and inadequate and like an imposter. I think a lot of people do. We don't always talk about it, maybe more these days. But I just want to say that, for me, really the last year has been a big change. This doesn't so much to do with the way that I work, just with other things in life and accepting my own value. But I hope that, for those of you who struggle, I just want to tell you you're not alone. And I can't tell you it will get better, but I can tell you that it can get better. So I hope it does. Okay, enough of that mushy stuff. Let's talk about programming. I want to talk to you today not about Rust exactly, but about this programming language I've been working on called Dada. And I wanted to use it as a kind of example of some of what I've come to think of as a good sort of research and development practice, both in terms of building the language design itself and implementing the compiler and so forth. But before I do any of that, I'm going to take you on a quick demo with the Dada playground. Let's see if I click here, will this work? Yes. So this is Dada, and this is a WebAssembly compiled version of the Dada interpreter. And you can see that it's interactive, and you can edit it. So the idea of Dada is it's supposed to be a kind of Rust-like language with permissions and borrowing and so forth, but with a feel that's more like a scripting language. And it's really got a heavy emphasis on interactivity. That's why, like, the very first thing I did, which I'll talk about later, is build a playground. And one of the things you can see here in this playground is, if I, for example, have a compilation error, like a parse error, it doesn't stop compilation. Compilation keeps going, and you can even run the code. And that's one of the goals, is that everything should be infallible. And if you think about it from like an IDE perspective or something, you can see why that would be something you would want. You want people to be able to be editing the code and be getting live feedback. And I would like them to even be able to run the programs and maybe run tests and so forth if the parts of the code that are kind of broken are not needed for those tests. All right, so that's the Dada playground. So the two main lessons, I guess, for me from this talk that I want to give across is that just like programs spend most of their time in loops, so do humans, and we should think about how we do those loops and try to make sure we're getting good value out of them. And secondly, that just like when you're writing a program, the choice of IR, of intermediate representation, can be the most important thing you do. So it is with development in general, right? I think I've often found when I'm trying to solve some really hard problem that suddenly the problem gets really easy when I just transform from the IR that I had to some intermediate form that highlights the aspects of the problem that are, or the aspects of the data that are most salient to the problem, right? Well, in the same way, picking the right tool as you work through can help you focus on the thing that you're trying to really explore most effectively, right? So let me talk a little bit more about loops. My experience is, I don't think I'm alone in this, that research involves a ton of iteration. You have some initial idea that you want to do, kind of an inspiration, but then you have to take a stab at it and then refine it and then over and over again. And sometimes it feels like you're just going in big circles. Hopefully they're more like spirals where you're kind of going in on something. Spirals getting smaller, not spirals getting bigger. That would be less good. But what I found from just a little reading is that this idea, doesn't just come up in academia. It comes up pretty much everywhere. And in fact, I hate to admit this, but my favorite version of it that I found is in a book written for startups, and they call it the build, measure, learn loop, where the idea is you have some idea for your startup, and you're going to build a minimal prototype, and then take it out and have people look at it, and then learn what you can from that, right? And the reason I love this so much is that it starts with build. My experience, I think, is often that I get stuck. I think, well, it would be best if I can just imagine what's going to happen. And so I work on paper, or I work in my head, and I do a lot that way. And that is true. I can work quickly in my head, but what I found is that I can't necessarily bring other people with me that way. It's much harder to convey to other people the idea of what I want to make and how it's going to feel. And in truth, it's even hard to convey to myself. But if I can build some kind of prototype and get something working, everything starts to go so much faster and to feel so much more fun. And the challenge is the building can take a lot of time. And if you try to build something perfectly, it could take years. So you really have to work as quickly as you can to get some kind of working prototype that you can present and think about and interact with. And I believe that if you do that, what you'll find is that it's going to spark a whole bunch of ideas on how to do it better. And the other danger of building a whole bunch of stuff is that you sometimes find that, well, in fact, you will, guaranteed you will find the first thing you build is not, in fact, what you want. So the more time you spend building it, the more of that time you potentially have to throw away as you change it. So that's why I started this talk with the Dada playground. And that's why I built the playground first, is that I really wanted something where as soon as possible, any change I make to the Dada language or any experiment I want to do or just want to feel how it works, I can throw it in front of people. But also, I think it gets people a lot more excited. I think it's a lot more fun if you can go to that website and type stuff in and get feedback than if you just see on my slides some ideas of what the syntax might look like, right? So even so, it took a while to get to the playground, right? And that's fairly late in the evolution of Dada. So let me start back and kind of walk that forward. The first thing is there was a spark. There was a reason I decided to undertake this project. And just to be clear, this is kind of a spare time project for me. It's not something I do in my work hours. Maybe it will become something, I don't know. But for now, it's just something I do an hour or so a day to relax, because I am odd like that and relax by writing compilers. But I had this conversation with someone who was a talented Java programmer. They were learning Rust, and they said that although they were pretty happily using Rust now and making good progress, they had tried a few times and failed, and that it actually took them like weeks to understand what a variable was in Rust. And when I heard that, I was like, oh my God, what's going on? Like, I feel like a variable is pretty basic. But I think I kind of got to understand what they meant, which was that, in Java and in many languages like JavaScript and so on, you can't really take a pointer into your stack frame and give it to another function. You can't have another function mutating local variables and changing their values. You just think about giving values from place to place, right? Variables are like a mapping from that your function keeps to a bunch of values, but that's all. Whereas in Rust and in C++ and in C, they really represent like a span of memory that you can address and talk about. And that makes sense. That's kind of a new concept. And even for a pretty experienced programmer, it wasn't something they had actively thought about. So as it happens, I had been working on, just over the years, thinking about ideas about kind of exactly that problem. I'd always been a little confused when people said Java doesn't have pointers, because it seemed like all Java had was pointers to me. But then I came to understand that they meant pointers into the stack. Right? And so I started thinking about what would that mean in Rust. And so the first thing I did when I heard that programmer say that was I started writing down type rules, because I wanted to make a better, more friendly, but also more expressive variation of Rust type system. And I started doing it on paper, but if you ever tried to write type rules on paper, you'll quickly find that that doesn't scale. It's just hard to keep them up to date and understand what they're even doing. So for me, the best tool for all of this kind of thing is PLT-REDX, which lets you use a really simple notation and then actually run the rules and see what their effect is. It lets you write unit tests. You can scale up much higher. And once you're feeling comfortable with the rules you have, you might take them over to some other format, like maybe you want to prove things about them, for example. I've never actually done that with any automated systems. I know other people have, so I can't speak much to that. But I find it to be a great system if you don't quite know what you want and you want to explore. This is a great way. And I spent a while doing that. And I think I got somewhere really cool. But well, before I go to the next step, let me just take you on a little aside. There's a really great book that I recommend that I've been reading and thinking about a lot lately by Felina Hermans, and it's called The Programmer's Brain. And it kind of explains why there's a limit to how much you can do on paper when you're developing type rules and things like that, and the value of tooling. It's kind of intuitive. It's basically you can't hold that much in your head at one time. And the idea is you can actually hold about 6 things, let's say, in your memory, where a thing is kind of a vague notion of what is a thing. It could be a lot of things, but that's sort of the value of abstraction itself, is that it lets you take one of those slots and store a really complex concept once you've found a way to represent it in an abstraction, right? Whereas if you don't have abstractions, you have to kind of use those slots just for low-level details. So in the case of the paper, I would say I can't hold all the type rules and see all their interactions in my head at once. I can hold a small number, and I can lean on PLT-REDX to help me with the rest, right? But the truth is that what I came to realize was working on the type rules was actually the wrong place to start. It felt good at first, it was fun, but it was actually kind of jumping, it wasn't really attacking the problem that I was most interested in. I was most interested in understanding how it feels to learn Rust better and how we could make that easier. And really any language with a relatively advanced type system. And so I backed up. I started to write tutorials instead for this language that doesn't exist. And I went through many drafts, right? First, I started just trying to write tutorials about the type system that I had been sketching with these type rules. And I realized after a while, I didn't think that was going to be a good way for people to learn. That what I thought would probably work best was a more interactive system where they don't have to think about type systems at all, but they just think about learning. They get errors and they kind of explore what kinds of things prompt errors and try to build a model for how the system works. And then they get type rules that they can use to capture that model and enforce it. And so I also realized a key part of how that was going to work then was going to have to be the interface. That it would have to feel, you'd have to be able to write code and get live feedback about what was going on. So I started writing a tutorial, and the challenge was I didn't know how to sketch the interface without implementing it. So I just started writing it in text. And maybe now I can kind of explain a little more concretely what I'm saying. I sort of said, well, imagine you have this program and you kind of put your cursor here, right? What you're going to see in this tool that I will build is a graph like this that's showing you, oh, here are your local variables. Here's the object you've created, this point object. And here's the permission with which you have to access that, right? Because Dada, this language is based on permission. So kind of the key difference from a language like JavaScript or Java or Python or something, one of the key differences anyway, is that each of your references will carry along a permission, knowing if it has unique ownership or shared ownership or what kind of access it has. And that lets us avoid a garbage collector and gets all the benefits that a Rust-like type system gives you, like freedom from data races and so forth. And so now I had these diagrams, I was able to better imagine how it's going to be, right? And I could build these diagrams really quickly. By the way, this is a great website, ASCIIflow.com. So I could build these diagrams really quickly. And okay, I don't like the way I ordered my presentation, so I'm going to skip ahead to here. And then I'll come back to the other slide. And what I could do, more importantly than building the diagrams, is I could start sharing them with other people. Right? This is where that feedback part comes from. So I could take this tutorial and send it to a friend who doesn't know Rust and say, read this and tell me, like, if you worked through this tutorial, would you be able to understand it? How much does it make sense? And people would read it and they would give me feedback, and usually they get pretty excited, which is cool, and they would say like, oh, but what happens if I do this? What happens if I write a program like that? And that would give me both a good idea of what to explain next, or perhaps a clue of what was hard to understand. And so I made a bunch of changes in that process too. And that was neat because I would change something about the language and then refactor the tutorial, right? So now that I no longer have a link between these two concepts, for example, I can reorder the chapters and I can just introduce one and then the other. So the more linear I could make it, the more it seemed like I was making progress. And so I want to take a little diversion to talk about this cool tool, Pernosco. So part of what was influencing me was this debugging tool, Pernosco, which I recommend as another potential tool, both for you to use, but also just to think about as a potentially inspirational thing. It takes RR traces. RR is a tool that runs on Linux. It captures your entire execution, and it will post them onto the web. And, well, not the trace, but it'll process the trace and create a web page for you that lets you sort of debug your program, but not like a normal debugger where you just say next, 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 but more like an omniscient debugger where you can go back and forth in time or trace data flow. And working with that, I found I was really coming to understand, or at least be able to visualize my programs much better. And that's what got me to thinking, well, if we had something like that, but which was visualizing not only the data, but the permissions, as you saw here in this slide, right? That would be really cool. So as I worked on this, I realized I kind of refined what I was trying to do. And I got some better hypotheses of the kind of thing I wanted to explore. First, like I said, that feedback was going to be really important. And that when you're learning the language, you don't just learn from sort of the syntax, but the environment around it. And the more interactive you could make that, the better. And that's because, at least in my experience, people don't learn abstract things like full stop. They learn concrete things, and then they can abstract from them, right? And that's kind of the opposite of whenever I want to explain something to somebody, I always think, I know how I'll explain monads or whatever. I'll explain the abstraction that I've got in my head, this like perfect simple concept, and it never works at all. But what works much better is to take one concrete example, work it through, maybe a second one, and then show them the pattern. And then I don't know, maybe they understand it differently in their own mind than I do. In any case, I thought similarly, if we could start with, think about real objects with permissions and that interact in definite ways, and then show how the type system adds on top of that and enforces it, it will work better. I think this remains to be proven. And finally, that I wanted Dada to feel like this normal GC language that we talked about before, that you weren't talking about places in memory, but rather values and objects. But okay, so at some point I got through this tutorial and I realized I wasn't learning anything new. Every time I sent it to someone, they just said, that looks cool, I want to use that. And I said, me too. But now I had a problem because I wanted to build it, but I didn't just want to build any old system. I wanted to build it in a specific way. Now, if you know programming, you kind of know what's coming. It's time for a yak shave. Take a little break from Dada and explore a nice framework for building compilers that I've been working on. So this has been a theme for me for a little while. I think when I learned how to write a compiler, I learned it in this style, what I call the Dragon Book style, kind of classic style, where you've got this series of passes that are going to execute one after another, right? So the compiler might have some source text here, take those source text, turn it into bytes, or rather read the bytes, turn it into tokens in Elixir, and then invoke a parser that's going to process those tokens and generate a symbol table, which will have like each of the functions. And for each function, there'll be a symbol data structure that will give its name and a link to, let's say it's AST, that's the body. And then once we're done parsing, we're going to take that AST and pass it to a type checker. And we're going to pass the result of type checking to an optimizer, and it's going to make some transformations. And then we'll go to code generation. This is a really great structure, not too hard to write, but it has some problems when you try to go to, say, an IDE setting, right? So this is how the Rust compiler was written, this pass-by-pass style. And when we wanted to build an IDE, we realized, well, this is like totally unsuitable. We need to, if we're going to do that, what we really want is to be able to sort of, well, we need to be able to process partially written programs. And we need to be able to do as minimum amount of work as possible to produce a particular result, right? So if you press dot and you want to know what is the type of the expression to your left, you don't want me to go off and compile the entire program in order to tell you the answer. You want me to just compile what I have to within that function, or at least just compile that function, right? And not go compile other functions. And the same thing applies to this highly interactive environment I wanted to build. I mean, in my ideal world, when you run tests, for example, I would like it to just compile what needs to be compiled, like just the code that those tests are going to use, and not the rest. So if you're just running one test over and over, you don't have to recompile everything, but just the functions that it accesses. And that demands a different style of a compiler, right? So when we made the Rust compiler incremental, which it is to some extent, we started playing with different schemes, right? And there are a lot of people here I want to give some shout outs and credit to. These are the like combination of Rust contributors and academics who kind of came up with all the good ideas I'm about to talk about. Uh, and so we wound up with this scheme that kind of made it automatic to build a more incremental, responsive, reactive style of compiler. And that's the scheme that's used both in the Rust compiler, but also in Rust Analyzer, which is the primary Rust IDE support. So how does it work? The idea is to work backwards, right? Like I said, you want to be able to get live feedback as quickly as you can. So if you're starting from one function, you just want to compile that one function and everything that it calls, but nothing else. And so what that means is you kind of invert the diagram, right? Instead of generating code as the last thing, that's actually kind of the first thing that happens is you say, well, I need to run this function, so I want you to generate code for it, right? So you start out here, but then the piece of code, the code generator says, well, in order to generate code, I need a type checked version of the source because I need types. So it invokes the type check function. And the type check function says, well, I can't, in order to type check, I need an AST to type check. So it invokes the parser. And the parser says, okay, I need to return a parsed version of main. So it might go and read the input, but not really the whole input, just hopefully the body of main, just as much as it can, and produce an AST, not for the whole program, but just for that one function, right? And then when the type checker returns, it can read that AST and maybe go for any functions that get called, like let's say main calls a helper function, we can parse them too, but we don't need to parse their whole body. We only need to look at the signature, right? Or at least we only need to process what are how many arguments does it take? What are their types? That sort of thing. That's what we need for type checking main, at least if it's a modular type system, like that can do one function at a time. And so we wind up with this sort of minimal thing, right? And parsing the signature will, of course, have to read something from the bytes. So now this is cool because now we have produced the code for main with kind of a minimal dependencies, but we've also given ourselves a pretty good idea of exactly what we needed, what were the requirements in order to do that. And that can then be used to drive incremental compilation. So the core idea here is fairly simple. If the bytes change, we can rerun the parser for the function body and rerun the parser for the signature based on the new bytes. They're going to produce new ASTs, and we can compare those to what got produced before. Because a lot of times the bytes have changed, but the output doesn't. Maybe they added a comment or something, or maybe they changed a different function. And in that case, the result will be the same, and we can skip type checking and code generation and so on. And you can structure this a lot of ways. I've simplified this somewhat. But that's the high level idea, is we want to build compilers like this. And we've been doing it for a few years. But the problem was the scheme, the library and crate that we had for doing it, or that I had implemented, was called Salsa, was kind of hard to use and a little mind-bending. So I spent a while building a new system, which I would love to talk about. I don't have time to go into as much detail as I would like. But if you're thinking of building a compiler in Rust, I think this new system would be pretty cool. It basically makes it easy to write compilers in that backward style, right? And no matter what language you're thinking of building a compiler in, I definitely recommend you think about it in this backwards, demand-driven way. And so once I had Salsa, then I could do this thing which I call a spike, which is a name I borrow from an ex-colleague of mine. But the idea of a spike is that you set yourself a kind of goal, and you do everything you need to do to reach that goal, and you do it in the way that you're going to want it done eventually. So you have some idea of the overall architecture you're shooting for, but you leave a lot of things undone, right? So I wanted to make Hello World work first. That meant I needed some way to print to the screen. It meant I needed a parser, and I needed a couple of, like a validation step that did some lightweight type checking. No, we don't really have types, but some lightweight checking, and then a code generator. But what I didn't need, for example, was binary operators. So the first version didn't have plus. and I needed string literals, but not integer literals, and so on, right? So I got that to work, and that was really cool and highly motivating, because now I can just work on extending it bit by bit, right? The interesting thing about spiking, though, is it works really well also with open source, right? So a big part of the work I've been doing has been around, in the open, in the Rust open source community. And there's a lot, I'm not going to be able to do a whole talk on that. There's a lot to say, but what I will say is that I think the key to building up, I think a lot of people would like to build up open source communities around their project. And one of the key things is doing this kind of spike approach of trying to lay down the vision you have, but leave lots of places for other people to fill in, right? And this might be relevant to open source. It might be relevant to other collaborators that you're working with, or students, or any number of things. And then that gives people a way to see where you're going, and have an obvious place to fit in and learn how the system works. And then you'll find that they kind of, if you find people who are excited, they build and they learn very quickly, because people are smart. But it raises this question, which is, how do you get people interested in your project in the first place? And there's a certain magic to that. But one thing that definitely helps is what I've been talking about this whole time, which is having a tangible demo that they can try out and really understand what you're trying to build and its benefits, right? So everything kind of fits together. And for Dada, for example, I think I'm pretty happy that I have the tutorial, because now if someone says, hey, what's Dada about? Instead of just pointing them at the compiler, which kind of half works, I can say, well, first read this tutorial. That's what we're trying to build. Now come play with its current status, right? It's not there yet. So you kind of have this combination of iterated on the lightweight way on the vision, and then the reality. And what I want to encourage you to do is, these days there's a lot of ways to make these tangible demos, and sort of systems you can fit into, such that your compiler begins to feel really polished with relatively minimal effort. Right. So one thing you can do is put it on the web, like we did with Dada, by compiling to WebAssembly. That's pretty nice. But you may or may not know, but like VS Code offers this thing called the language server protocol, which is really cool, and basically separates out the language and the error messages and so on from the editor, right? So Emacs and VI and every editor that's worth its salt supports the language server protocol, as does VS Code. And so if you implement that, you can kind of integrate with people's editors in a very lightweight way. And I would say that if you have built in this style I'm advocating, this working backwards style, then that's a great fit for the language server protocol, because you're getting exactly the kind of events and so on that you can feed into that system and then just get back the results. And finally, some amount of polish around the edges, things like great error messages. That really helps people to learn your system. It also helps you to think about how your system works. There's some really cool crates in Rust. Like, I didn't write all that Unicode stuff you saw. I'm leveraging Ariadne, but there's some really great crates you can use to do that. Okay, so that covers the high level view of what I wanted to say. I'll just throw in a few bonus items. One thing is, I've kind of been talking about how you pursue and explore an idea, but you have to get that first spark of an idea in the first place. And I actually saw there's a talk coming up on this, so maybe that author or speaker will have better advice than I do, but I'm not really sure the best way to do this. But what I found, what works for me, is essentially take something you admire and try to reproduce it, and just work in that area. Don't try to make something new. Just try to work and play and learn how things work. And along the way, you'll find that there's problems. You'll find that once you do the examples from the paper, they work fine, but as soon as you extend them, they fall down somewhere. And something will take you in a different direction, and that becomes a project. So that's one way. Or maybe somebody is able to guide you and suggest projects to you. That's also great. Another thing, people often ask about cool books. Just want to throw up a few links to books I think are really great. Types in Programming Languages, classic. Retargetable C compiler, another classic. And Building and Optimizing Compiler, sadly out of print, but a great book for if that's not for type systems and things, but for learning about optimizations. All right, so that brings me to the end of my talk. I hope something here sparked an interest for you. I want to say, I guess, if I were going to summarize this strategy of what I'm saying, it's something like this. And this is a formulation that I got from Yehuda Katz, who is a great collaborator and friend of mine and who works on a bunch of open source projects. And the way he sets himself up to work is if he's got a new idea, he gives himself 3 months to build a prototype. And sort of prove the idea out, right? And in those 3 months, he allows himself to focus on that all the way. And then at the end, he either has something he can demo or he's kind of found that it's got to a dead end. I don't necessarily follow that in such a strict way, but I think this idea is basically right. Find yourself a goal, build some kind of prototype, and if it's going to take you a while, you're probably building it wrong. You should probably go back, right? Maybe you just want to write a tutorial instead. Maybe that's your prototype. But something that lets you then go to other people and get feedback and also get it from yourself. And do that as much as you can. Try to shape out your vision so that you've got a pretty good idea what you're shooting for before you begin writing code or anything else in earnest. And then once you write your code, you can do that spike style, which you'll be able to do because you have a kind of overall view of what you're trying to achieve. And write it in backwards style, and go ahead and write it in Rust too. I think that would be great. But use whatever language you want. They're all great. Anyway, thank you very much. If there's time, I'm happy to take some questions and so forth. And enjoy the rest of the session.
Thank you so much, Nico, for this great talk. So we're happy. We have time for a few questions, maybe one or two. I rely on the student volunteers in the audience. We haven't heard a question yet. Okay, so do you have any recommendations of books about incremental compilation?
I don't know if there even are books. I know that there's a bunch of active and exciting research. So I mentioned Matthew Hammer. His Adapton system is the one that I've used the most, but there's other directions like contextless type checking. I don't remember the names off the top of my head, but I can dredge up some resources. Anyway, I would look more in academia myself, but I think there's some pretty exciting work there.
Okay, so maybe we have time to take another question.
Oh, just one addendum. I just remembered the work that's going into is now going into the Materialize startup by, oh man. Well, anyway, I'm so bad with names. I'll have to go find the names. But there's so much exciting incremental work out there.
So maybe if there's no one in the audience with a question, then let me maybe ask a question, kind of connecting a little bit to our panel earlier. You've done a tremendous amount of work in Rust, and that we all know that there is a lot of effort and time, also commitment that goes into that. So how do you balance your work life with your private life? Do you want to comment on that?
That is a real challenge. Yeah, I will comment. I mean, I think there's some basics like establishing kind of time boundaries and so on, but that's only goes so far. I think what I find hardest about working with Rust is that there's just so much happening and there's like infinite time that I could use to invest. So how I choose to direct my energies becomes sort of the most important thing to answer. And, you know, I mentioned having sort of felt more at peace in the last year. And I think a big part of that is kind of coming to accept, A, you're just going to do the best you can and you'll never be able to stay on top of it all. That's one thing. But B, and I guess having some idea of what you're trying to work for, so that I mentioned that if you iterate like on this tutorial and you have a vision of what you're going for, that can kind of help keep you on track already. So that can kind of give you some prioritization as you work through it. And there was, I guess, those are the two biggest ones for me that I've learned and been working really hard at. Is trying to connect everything I'm doing to the goals and work with people and accept that there's always going to be some amount of chaos, and that's kind of the nature of life. And so I'm doing my best to navigate it and work with it and make progress.
Okay, thanks a lot, Nico. When you mentioned like there's always a certain amount of chaos, I think I agree with you, and I think we have to accept it, kind of. That's yeah. Okay, so we all thank Nico a lot for his talk, and I